Section 2, Video 5, Operations with Radicals, Multiplication and Division. As with addition and subtraction, we have certain characteristics we must pay attention to. We have, first of all, the fact that when we multiply radicals, we will multiply coefficients with coefficients and radicals with radicals. That's how they go together. However, in the end, we must make sure that we simplify. The distributive property works. Again, be sure to simplify. And FOIL works, but again, make sure you simplify. So you're just multiplying, and you have to remember the rules. So we have the rules that say when you multiply outside numbers or coefficients times coefficients. So here's a -1 times 3, and we get -3. And here's root times root, and we get root 36. Again, make sure you simplify. In this case, the root of 36 is 6 times -3, and you get -18. Next one, you have a choice here. You can simplify first, then multiply, or just multiply and then simplify. In this case, I'm just going to follow the same pattern. We have a 1 out front. Multiply the coefficients. 1 times -2 is -2. Root times root, 12 times 3, we get root 36. And again, we know that the root of 36 is 6 times the number that was already out there, and we get -12. Here's another scenario where we're asked to distribute. So we would follow that process of appropriate distribution. The first one we find that it's root 5 times root 2. So we can multiply. Actually, you know what? I'm going to do this. Just to make sure we understand that distribution has occurred. And now we can follow our rules and say that these are both in the root. So we have root 10. These are both in the root. We have root 30. We ask ourselves, can we simplify root 10? Can we simplify root 30? Neither of them have a perfect square that goes into it. If I were to find the prime factors, nothing would work there as well. So this is as good as it gets in terms of simplifying. Look at the next one. Remembering a very important rule that I cannot distribute a power, okay, because of the addition. If these are being multiplied inside there, I could distribute the power. But when there is an addition or subtraction problem in there, we cannot do this. So this is actually a clever way of showing that you have a binomial times a binomial. So we have to FOIL. So first times first gives us root 2 times root 2, which is root 4. Outside gives us root 10. Inside gives us root 10. And last gives us root 25. So we have root 4, which is 2. We have root 10 and root 10, which are exactly the same. So it's just adding like terms. So we have 2 of them. And root 25 is 5. So these are like terms. So we have 10, or excuse me, we're adding them, not multiplying them. So we have 7 plus 2 root 10. So here's another example. It's a FOIL question. So first times first gives us, well, it's a 1 on the outside, so we get 5 times root, and root times root gives us 9. Outside gives us a negative root 12. Inside gives us a 5 root 15. And last gives us a negative root 20. So now we just need to simplify. Root 9 is 3 times the number that was on the outside already, so we get 15. Minus, well, root 12 is 4 times 3. Root 4, so now if we root each one, root 4 is 2. We still have a 3 on the inside. We cannot simplify root 15. Root 20 is 4 times 5. Put them in their own roots. So root 4 is 2. Notice the negative is still there. Root 5. Now if you look at this, we have no other like terms. There's no roots that are the same. So this is as simplified as it gets. And this ends section 2, video 5.